Okay, I just wanted to give you another example of how the standing wave occurs. And again, just to emphasize that what you will see, especially in the lab that you do, is that it looks like the string is just bouncing up and down in certain spots. But what's really happening is a wave is traveling forward and then traveling back again. So here I've got a wave coming down. This is going to take a while. I don't know how to speed it up. But so here would be perhaps me agitating the string at this end and then sending the wave down. It's going to become reflected then, as we talked about in the last example. It gets reflected underneath. And then you'll be able to see that the one wave, the reflected wave, is going to be in blue. And you'll be able to see that the reflected wave is then heading toward the original wave, and it's canceling it out or adding together. So notice when the black line gets really high, that's when the blue wave and the red wave are overlapping. Or when the black line gets really low, like here, you can see it's when the blue and red are perfectly overlapping, they add together. Now, where they cross, they're canceling each other, such as here, and that's where it's 0. Now, if I turn these off, you'll be able to see then what it really looks like is this. This is what it'll look like in the lab, but of course moving way faster than this. The vibrations, or the frequency we're using, is a couple hundred vibrations per second in the lab example that Mrs. Whitehead and Mr. Rusnick recorded a couple days ago. So again, this is what's happening though. As you see, this is what we refer to as a standing wave. And again, we have the nodes are here where you have perfect cancellation, and your antinodes are where they cross and they actually add together to give you a double amplitude, both waves adding together.